Yeah, so hello everyone. This is the second presentation on machine learning with Python. First, we discussed on the AI and machine learning and went through some of the ideas in machine learning. Here, we'll see some of the implementation of normal Python before we actually get into the machine learning. So we'll be discussing here Python, Jupyter Notebook, and just going through some of the normal topics in Python. So before we get started with Python, I will go for a Jupyter Notebook first. You can use a Jupyter Notebook by going through the link and following the steps to install the Jupyter Notebook on your uh, respective device or version, OS version, whatever you are using. So you have it for the Windows, the Linux, and also the browser-based one. This is how somewhat it might look like in the whenever you are using it and are done installing, and you are using it for the code. So let's get started with the concepts in Python. So first is a normal print statement, how we print the statement. We are using it hello, and then we use a variable and using a print statement on it to print the value of the variable. If we run it, it will give 5. If we change it and 6, it will give us 6. After that, we are using for the variables and the types that are in the variable. So starting with it is an integer type, the float type for decimals, then Boolean type for true and false, string for containing the characters and characters in a string form, then dictionary for key value pairs, tuples, list, and set. So tuple and list, we will see how they differ. Then set for containing the unique values. And this is the print. And this is how print function executes. Objects are the ones that are needed to be printed. And then separations and end with normally a new line. So here are some of the variables defined, and they are of different types and will print those variables. As you can see, where one is an integer type, will print those variables as well as print the type. So you can see starting from end till we have for dictionary tuples, list, set, and all. So let's run this cell. So you can see that for value of var1, which is an integer, we are getting a class int. And then for float, and then and so on for all the respective ones. For dictionary, we have dict, then tuple for tuple, list for list, and set for set. Next, we have conditional statements where we set conditions in order to execute certain things, and or up to certain conditions have to be satisfied in order to execute that part of the code. So as you can see, we have values of x equals to 10, y equals to 12. Then we are keeping an if condition for printing. If x is greater than y, then print this. X is smaller than y, then print this. And in the end, if not both of them, then x and y are equal. So if I print this, it will print x is smaller than y because it is, as x is 10 and y is 12. Next is generating the numbers using a range function. So you can see the syntax of a range function. We have the starting condition first, then we have the ending condition, then the step. So step is if generating a sequence of number starting from 1 to 10. Here you can see, then it will print. If we give the step value of let's say 2, you'll see the difference of it creates. It will skip every value, second value, and move further. By default, this value is 1. So if we type print same result as before, if I remove this, it will still create the same list. Then we have control flow statements, starting with for loop. We have the sequence, and we are going to iterate the sequence using I and printing the values of sequence that we have created using the range function. So you can see we are getting this. And also one thing to note, remember that this value is not included whenever we generate the list. Then we have control flow statements using while loop. So first we initialize the value of I with 1, and we have to keep on, whenever we have to keep on printing or executing, keep on executing a block of code until a certain condition is met, we use a while loop. So as you can see, we have a I smaller than 5 till that it will keep on printing the value of I, and while incrementing the value of I. As soon as I becomes 5, it will stop implementing it and print done. This is how the output looks like for it. Next, we have functions. So functions are basically, as you saw, that we kept on, we do not have to hard code everything for doing it, and we can rather save it under one function to do a certain kind of functionality. For those, the functions are used. So you can see here, we have a function. We use a def keyword to define a function. We name it greet. Then the function asks for the first name, the last name, the country of the person, and then the person enters, and the print statement. So after that, we got it. So here you can see that when we run the cell, it will ask me the name. So we have it, then for BS, then for country. So you can see the output it gets. Now let's see the second example of a function. We use mathops. We name it mathops, which asks for these arguments. And so how it will work is that if the operations value will be equals to add, it will add the number, and if the operations value will equal to sub, it will subtract the number. And this is how we will see whether the add string is inputted by the user or substring is sub is given as an input or add is given as an input. Then a user enters the number, first number, then second number, and gives us the result. And we save the result in result. So let's run this code cell first. We use add, then we use first number is 1, second number is 2, the answer is 3. We again use it for sub quickly. We have sub, we have 5, we have 3, and the answer is 2. Next is working with collections. As we have also mentioned, list, tuples, set, and dictionary before also. So let's start with sets defined with square brackets and which contains different values within it. So we have the list of color, list of shapes. So starting with colors, if you want to simply print the list, we use it this way. If you want to access the list, you can use it this way. And if you want to reach at the last value of the list, you can use -1. So -1, if you know the, let's say you know the list over here only. The colors contains starting from 0, we have 4 till 4. So if you enter 4, it will give us purple. But this is not the case for longer values. So using -1 is a better option rather than that. Then we have the start value, using the start value and end value here until we want to print the list. You can see the start value here, and you can also see the step function being implemented here also. A step feature implemented over here also. So after that, if we want to add the list into one list, you can do it this way, and it will add it. So, and whether you want to check whether certain element is in the list, you can check it this way. We'll see when we run the cell. So when we run the cell, as you can see, the first one was to simply print the list, colors list. It was this. Then we use colors 3. The colors 3 has 0, 0, 1, 2, and 3. It is yellow. It is printing yellow. Same for no. We wanted to access the last value in the shapes, which is hexagon, and as we entered -1, we got it -1. Then we wanted to iterate the list in a reverse order. So for that, when we use a -1 in the steps space, it will reverse the whole list. So you can see the reversed list over here for the original list over here. Then we have the start and slice list, which will start with this and end at this. So we have the start slice over here, which is and of course it will not contain the third element, so it will stop before it. So we have a start is red and the end is green. Same here for we started with red and we printed till the end of it. Then we also used a step function for skipping the starting with red, skipping green and stuff. So step here, step is by default 1, so that's why it didn't skip anything. But if we change the value, it will skip. And because we checked for circle in shapes, there is a element named circle in shapes. It will give us a true value for it. Next is two ways of inserting elements in the list. One is insert 5, which will insert at the 5th index and give us which will give us the value black, which will add the value black. And if we use append, which will always do it at the end of the list, it will be in the using this way. And if we print these, it will give us these values again. So if we say, let's say just clear this, so you can see the, so these are the change, these are the elements that were added, and these are the elements that it also printed for the changes that we have made. Next are tuples. So the difference between lists and tuples is that as we can add and add or modify modify the list, tuples are not. Tuples cannot be modified. They cannot be changed. So if you want something that has to be fixed, you can use or go for tuples. If you want something that needs to be changed and or modified frequently, you should go for list. And because tuples are not mutable, they don't have much of the operations unlike list. So as you can see, the tuples are done with rounded brackets, and if we print this, it will print. But if we, so let me run this cell first. So as you can see, it's running this cell and giving us this value. But if I try to add orange in this, it will give us the error. Tuple does not support item assignment. Next is a typecasting a list into a tuple. So we have colors one as a list which is typecasted into tuple and stored into colored tuple. So you can see colors one was colors one is a list, and it will be typecasted into tuple, so it's returning a tuple. Then we have sets. So sets contain unique elements, and they do not allow duplicates. So we have a set of numbers over here which contains these values, and when we try to print these values, as you can see, we have two ones over here, but it will only print one over here once. See, so some of the operations regarding sets, we have two sets over here, and you can see their elements. So we have union of two sets. It will create a union which will include all the elements without any duplicates. Then we have intersection for all the common elements of both the set 1 and set 2, and difference for having the elements that are not present in comparing the elements of set 1 with set 2 with elements not being in set 2. Similar, so there are two examples we can do it. So first is for set 1 minus set 2, and then second one is set 2 minus set 1. So let's run this cell first. So as you can see, we have union, we have intersection of it, which are normal and common. But then we have set 1 minus set 2. So elements that are present in set 1 but not in set 2. So these are 1 and 2. And similar for set 2 minus set 1, elements that are present in set 2 but not in set 1, which are 6 and 7. Next are dictionaries. Dictionaries are key value pairs. So we have a dictionary with a key value pair of Olympic winners, the countries which won, how many, which countries won, and how many of them won, which, how many of them and stuff. So so these are the countries and the values. And for Olympic 2016, we have these values or in this dictionary. And for 2020, we have this dictionary. So we can simply use these statements in order to get the value of for 2020 and 2016. So if we use the key USA here, it will give us the value this. If we use key for 2016 over here, it will give us this value. For printing only the values, you can use values like this, and for printing only the keys, you can use keys like this. And so let's first run the cell. So you can see the values that we get over here. So the last for loop will be iterating like this and giving us output in this manner. Next is the Cricket World Cup's winners and how many of them are there. So these are the values where keys are the years and values are the countries that won. So let's say so we just saw set. So if we typecast these values of WC winners into set, it will give us the unique value of how many countries have won the World Cup. So if we run this, so you can see the values over here. So let's start with strings now. So these are the different strings and which are done in this way. Just a second. So yeah, so you can also use single quotes, the double quotes, and triple quotes for multi-line strings like this. For converting a string into uppercase, you can use upper and lower functions. Then making a string into tokens, you can use a split function like this with a space to create it. So if we run this cell, it will give us this value. So as you can see, the Python has been capitalized or uppercased. Then we lowercase machine learning, which is for M and L being uppercase, and then we separated the values of from the string machine learning and have every word in the string as a token. Next is functional programming, which helps us to pass functions as parameters, which helps in replacing the looping things that we have been doing. So we can use a function with an iterable, and it will this is what we are trying to achieve in functional programming. So let's start with a simple basic idea of what we are trying to do. So first we have the list, then we have a empty list of square list, where we'll be appending the results of the squares of the int list that is over here with the help of these for loop. So if we run this cell, it will give us these outputs, where you can see the squared output is over here, but it takes these many lines to do this, at least these. Then we use a map function, which will take a function and an iterable as an input and give us the output, which takes only this one. So every time we want to use this, we can use it for with different iterables. So this does the same thing with small lines of code. And further, if we move, we can use a lambda function as well. Lambda is also known as an anonymous function, where you can see you can use a single expression with like this. So which will be implemented on int list. So you can see the expression over here. If we print this, it will give us the same value that we have been using. So in a way, you can say that it just created a function in a single line of code that these contain two. This contains one line, but these contain 3 lines to execute. Next is a filter function. What does a filter function do? It basically filters the values based on the condition. So here we have a nums list, and what the lambda function is doing is checking whether it's divisible by 2. If it is, it will add it into the even nums list. As you can see, we have typecasted it over here in list. So you can see for the list, it is returning these values. Then for modules and packages, what are modules and packages? And these are some of the functionalities packed into a package, which we can import and import their their special functionalities that are defined in those packages and use them for our use. So a simple one is that there is a time module which will be importing, and then we'll time the execution of the program. So when I run this, you get the execution time of it. You can see this is how much it took to run this program, which counts through 1,000 till 1,000. Next is a import function of math, which basically uses a square, gives us the square root of the given value. So this is how you can access it's you have the module, you have the method for, and then give the parameter. So you can see that it has the it has the output. Now then we use a random for using random, we import sample to create samples. So there is a so just as we used a range function to create a sequence, first we'll be using the range function to again create a sequence over here, and we need 3 samples in it. So as you can see, if we run this code, it will give us 3 samples every time randomly from the given range. So if we run it again, it will give us again the new values with 3 samples in it. So the fourth example is somewhat similar as well. It will always give us 20 values for the given range. So, for the one of the practical use, I will not go more into detail. We'll discuss it whenever we will go into we'll be discussing it in future session. So this is this is how the random one that we used can be used over here. So we are basically, what we are doing is that we are reading a CSV file, which is a comma separated file named sample data set. Just a second. So we are just simply using a sample data set .csv, and then for counting the number of rows, this is how we can use. Then we are creating a random sample from the number of rows, using number of rows as the argument in the range function, and creating 10 samples from the given rows. So you can see that if we run this, it will create 10 samples using this. Every time we run this, it will create 10 samples. So last is the using mean median for mean and median function, and how to get it. So we have this as the input. Remember this, and this is the random list that we'll be using. And if we execute it, it will by calling this into mean and median, and then printing their values. So if we run it, it will give us this values. So yeah, so this is the this was some of a simple walkthrough through some of the concepts in Python, though each one of them can be their own dedicated video. But and this was just going through some of them in general. And you can see use these references, and also some of the YouTubers that are doing a fantastic job on covering various other Python concepts. Corey Schiffer is one of them. And then we have Free Code Camp and stuff. Many other YouTube channels. So yeah, thanks a lot for listening, and we will be continuing this series further also. So yeah, thanks a lot.